Corporation presents engine teardown, cleaning, inspection, an essential skill. Almost anyone can tear an engine apart, but only a well-trained technician knows how to do the job right. Proper disassembly techniques will prevent part damage, allow for essential part inspection, will result in good component organization, and will save time during engine reassembly. This video will demonstrate the most important tasks for properly disassembling an automotive engine. It is designed to apply to any make or model of engine and should help you in working on any car. The use of special tools is stressed to help save time and to do a superior engine rebuild. Lifter pullers, wheel pullers, ridge reamers, and other specialized tools are demonstrated. The video covers fundamental service procedures like thorough parts cleaning and tricks of the trade like where to look for potential trouble on parts. Remember, a shade tree mechanic tears an engine apart in a rush. A technician methodically disassembles an engine while collecting information to improve the repair job. Engine technology and auto mechanics in general is changing very rapidly. Anyone who thinks they know everything in auto mechanics is a fool and is going to be left behind. A very important rule. Try to learn something every day that will improve your skills. Then you'll become a better automotive technician every day. These part failures resulted from improper engine rebuild techniques. During engine repair, small mistakes can often result in serious part damage. How would you like to explain this whole block to a customer after you've worked on the engine? The customer would not be very happy. Front end disassembly. Engine teardown is simplified if you take a couple of minutes to mount the engine on an engine stand. If you're using a chain, make sure the lift bolts are large enough in diameter and that they thread into the part at least 1 1/2 times their diameter. Snug the bolt down completely. It should not stick out from the engine, but should clamp tightly on the chain. You should also form an eye in the chain with a bolt and a nut. This will keep the hook and the hoist from slipping. It is dangerous to place a lift hook around a chain not formed into an eye. The chain should be fastened to opposite corners of the engine so the engine is lifted level. Mount the engine stand arms onto the engine while it is still on the ground or shop floor. Again, make sure your bolts thread in 1 1/2 times their diameter so they won't break off. If you ever drop an engine, you might get lucky and only lose money replacing parts. But you could also lose a foot or a hand. Raise the engine slowly while keeping all parts of your body out from under the heavy engine. With the engine in the air, fit the engine stand together and secure it with bolts. With the engine on the stand, you are now ready to begin disassembly. Most crankshaft dampers are held in place with a large bolt. Remove this bolt before trying to remove the pulley. A few dampers are press fit, however. Remember never to pry on the outside diameter of a damper or it will be ruined. Mount your wheel puller so that it is square on the damper. Oil the puller threads, and then use an impact to force the pulley off the crankshaft. Wear safety glasses. If a bolt breaks, it can shoot out with blinding force. With the damper off, you can start removing other front-end parts. Use common sense on deciding part removal sequence. If you have a timing belt, remove its cover while keeping bolts organized. Remove belt tension by loosening the tension adjuster. A used timing belt is normally replaced whenever it is removed from an engine for service. It is relatively inexpensive, but is critical to engine service life. If a timing belt fails, serious valve and piston damage can result. Parts with a gasket may require light prying or a rap with a mallet to free them from the engine. Use a soft face or dead blow hammer to prevent part damage. Timing sprockets are usually secured with a bolt, but they can also be press fit. If held with a bolt, light prying will usually free them. Sometimes they will slip off easily by hand. Here the mechanic is removing the backing plate. If a sprocket sticks to its shaft, use a wheel puller or light prying to remove it. Do not hammer on a timing sprocket. When prying off covers, be careful not to gouge or nick the sealing surface. Use a wide blade tool and drive it between the two parts and pry lightly. Here is a badly worn timing chain. After removing the cam sprocket bolts, pry lightly to remove the sprocket from the cam shaft. Head removal. To begin, remove all external parts like this carburetor. If the carb is going to be reused, keep it level when removing it from the engine. Remove the intake manifold. Taps from a mallet will usually free the gasket material. Also remove the exhaust manifold. When removing the valve cover, be careful not to dent or warp the gasket sealing surface. Next, remove the head bolts. Normally you can use an impact to save time. Once all the bolts are removed, pry lightly to free the head gasket from the block. Sometimes the head gasket will stick, and you must lift one end of the head to tear the gasket free so the head can be removed. If the engine is warm, you should go ahead and scrape gasket material from the block and the head. When the material is warm, it will scrape off more easily. With a push rod engine, you can sometimes remove the head with the rocker arms and push rods in place. Remember to always keep parts organized. They can be select fit, and this will also help problem diagnosis during part inspection. Lay the push rods in order inside the block. Then you could place them in an organizing tray like this one. Next, you might remove the lifters. Here's a lifter removal tool. When you push down on the knob, the end of the tool expands and locks onto the lifter so that they can be slid out of the engine. Sometimes lifters will stick in the lifter bore. This is due to a buildup of oil film on the lifter. Jerk back and forth on the lifter to free it from the cylinder block. If the lifters are going to be reused on the camshaft, they must be kept in order so that they can be reinstalled on the same cam lobe. A bolt installed in the front of the cam will help camshaft removal. As you remove the cam, rotate it and slide it out slowly. You don't want to nick and mar any of the cam lobes as the cam is removed. If the cam might be reusable, place it somewhere where it cannot be damaged. Piston and rod removal. To begin bottom end disassembly, rotate the engine on its engine stand. This will give you access to the oil pan and connecting rods. Tighten the bolts on the engine stand so that the engine cannot flip over. Remove all of the oil pan bolts. Use the same general procedure described earlier to remove the oil pan. Force a wide, thin blade tool under the pan flange and pry up lightly. Try to avoid bending the flange because it will have to be straightened upon engine reassembly. Inspect inside the oil pan for debris. Particles indicate engine problems. A bit of aluminum might be from a piston skirt, for example. Unbolt and remove the oil pump next. Then check the connecting rods for markings. Each rod should have a number on the cap and on the rod body. If numbers are missing from the rods, you must number them. This will let you keep the caps and rods in order. If a number is not on the rod and cap, use a number set to stamp the number into the rod and into the cap. If a rod cap is installed on the wrong rod, the rod bore will no longer be round and serious problems will result. You should also make sure there are numbers and front arrows on the block main caps. They too must be installed exactly as removed to keep the main bore in alignment. Mark them if needed. Before piston removal, use your fingernail to feel for a ring ridge at the top of the cylinder. You must remove any ring ridge to prevent piston damage. If you try to drive the piston out over the ridge, the rings will catch and damage the ring lands. Use a ridge reaming tool to cut any lip out of the cylinder. Mount the ridge reamer into the cylinder. Then adjust it outward until it is snug against the cylinder wall. Do not over-tighten the tool or it will not turn freely. Mount a ratchet on the larger drive nut of the ridge reamer. Rotate the tool in a counterclockwise direction. Slowly turn the tool while watching how much metal is being removed. You only want to cut the lip flush with the worn cylinder wall. Readjust the cutter after about 2 or 3 revolutions. Occasionally feel the lip to make sure you're not cutting too deep. Once the lip is cut flush, remove the tool and go to the next cylinder. Here you can see where the lip has been cut almost flush with the cylinder wall. Use compressed air to blow shavings off the top of the pistons. These shavings could scar the piston and cylinder during piston removal. Use a plastic or wood hammer handle to push on the bottom of the connecting rod. Slowly force the piston and rod out of the block. Use one hand to grab the piston to prevent it from dropping out of the engine and onto the shop floor. Repeat this operation on the other piston rod assemblies. Again, be careful not to let the piston fall and become damaged striking the shop floor. You should install a rod cap and nuts back onto the correct rod body. Try to place the nuts on the same rod bolts with the shiny or same side down. Place the piston rod assembly into an organizing tray or in sequence on your workbench. Crank removal. Begin crankshaft removal by unscrewing the main cap bolts. Again, make sure they are marked first. Tap lightly on the cap to free it from the block. Then use the bolts to lift the caps upward. Carefully lift the heavy crank out of the block and place it where it cannot be damaged. Pop out the old rear main oil seal. A screwdriver under one end will usually free it. Then use your finger to pry out and remove the main bearing inserts. If a high mileage engine, remove the black core or freeze plugs. Drive a pry bar through the plug with light hammer blows. If the plug falls down into the engine, use needle nose pliers to retrieve and remove it. Ideally, the plug will puncture or spin and not fall inside the block. This will let you pry the core plug out of the block more quickly. Be careful not to damage the block sealing surface, however. This is a ring expander tool. It can be used to remove and install piston rings. Note that it has an adjustment nut to help prevent overexpansion of the piston rings during installation. If you're going to mount the piston rod assembly in a vise, use soft lead vise caps. They will prevent marring and damage of the rod I-beams. Carefully mount the piston in the vise and lightly snug it down. Do not over-tighten it. Remove the old piston rings. Here the technician is using the ring expander tool. Normally, start at the top and work your way down. You can also spiral the old rings off by hand. Use your fingernail to grab the ring and then twist it and pull it around the piston. You're not as concerned about breaking the old rings as you are when installing new ones. Also lift off the expander spacer from the oil ring. Hard cleaning and inspection. Here is an important cleaning tool, a piston ring groove cleaner. It must be utilized on reused pistons to remove carbon from inside the piston grooves. It has several cutter widths to match the ring groove widths. The tool is spring-loaded and will open and close to clamp around the piston. To use the tool, insert the correct size cutter into the piston ring groove. Then tighten the tool down around the piston. Slowly rotate the tool around the piston while watching inside the piston ring groove. Only cut out the hard carbon or until the inside of the groove is shiny. Do not cut too deep or the piston could be ruined. As you can see, we've only cut the carbon from the inside of the groove until the surface is shiny. If you cut too deep, it can weaken the piston and cause it to fail in service. Repeat this operation on the other ring grooves. Note how the carbon is being cut out of the groove. If the carbon is not removed, the new rings could be jammed against the cylinder walls, causing the rings to freeze against the cylinder during engine operation and break-in. Use a dull scraper to remove carbon from the top of the pistons. You could also bead blast the piston heads. Try to get as much of the carbon off the pistons without marring and scratching the surface. Blow metal shavings off the piston and inspect them for damage. If you have floating piston pins, use snap ring pliers to remove the lock rings. Wear safety glasses and insert the plier tips into the snap ring. Squeeze on the pliers to compress the snap ring and free it from its groove. Repeat this on the other snap rings. Use a driver and light hammer blows to push the piston pin out of the piston. If you have a press-fit piston pin, you'll need to use a hydraulic press and special driving tools. Never try to use a hammer to remove a press-fit pin. Remember to always clean all engine parts thoroughly. Scrape all old gasket material off and wash off dirty oil in a cold solvent tank. Remember that if you leave even one bit of old gasket material, it can lead to a serious oil or coolant leak and a comeback. In auto mechanics, cleanliness cannot be overstressed. Even one speck of metal left inside an engine could freeze an oil pump or score a cylinder wall and cause serious engine damage. Wash both the inside and outside of parts thoroughly. A good mechanic will spend almost as much time cleaning parts as on any other operation. As you wash parts, inspect them for signs of trouble. You might inspect a piston for cracked skirts, damage to the piston head, damage to the ring lands, and other problems. Do the same as you wash the connecting rods. Look for marks on the I-beam. Look at the inside of the big bore for signs of rod-bearing movement, and inspect the small end for signs of bushing wear. Wash off all the piston pins. If the pins look good, mic them and check them for wear. If they show definite wear patterns, just replace them. As you clean the rocker arms, inspect their wear points. Check the tips for signs of wear, and also check inside the rocker arms. Also clean off the lifters while inspecting them. Never soak lifters in solvent. This could allow them to fill with solvent. Thorough cleaning of parts will allow more close inspection and precise measurement. Clean the outside of the push rods. If they are hollow, run a piece of mechanics wire down through them. This will help force out any debris that has become lodged inside the pushrod passage. If installed in an engine, a clogged pushrod could lead to rapid rocker arm wear because it would starve the rocker arm for oil. Use solvent and compressed air to clean the inside of the pushrods after using the piece of wire. After cold tanking parts, blow all parts dry to ready them for inspection. Wear eye protection and blow away from your body. To inspect a rod, look inside the rod big bore. Any signs of bearing movement will tell you that the rod may require rebuilding or replacement. Inspect the rod I-beam. Any marks like this would require rod replacement. Also inspect the rod's small end for signs of trouble. Check the rod bearing for size markings. The letters S, T, D mean the crankshaft and bearings are standard size. .010, .020, and other numbers normally mean oversized bearings and a turned crankshaft. This connecting rod bearing shows signs of normal wear. Any bearing damage would also mean potential connecting rod damage. This is why it's desirable to keep all parts organized together. This is a badly hammered rod bearing, indicating the need for a rod rebuild or rod replacement. This piston has been hitting the cylinder head. This would tell you that the crankshaft, connecting rod, and bearing are also badly damaged. Proper piston skirt inspection is often overlooked. A piston skirt can wear or crack easily. If you overlook a cracked skirt, the piston could quickly fail in service and cause damage to the cylinder block, connecting rod, and other internal parts. Here's a burned piston. The ringland was actually blown away. The top of the piston is also holed, causing the engine to pump tremendous amounts of oil. Piston pin clearances are normally given in 10,000ths of an inch. This makes even minute wear critical. This first pin would have to be mic'd. However, you would know from inspection that this second pin has to be replaced. Check the rocker arms closely for wear. Inspect at the point of contact for the push rods and valve stem tips. These rocker pivots are very high wear points and normally require replacement. If worn and not replaced, valve train clatter can result upon engine reassembly and operation. The bottoms of new lifters are actually crowned or humped. Worn lifters like these will become concaved or dished. This would often mean that both the lifters and the camshaft should be replaced. Lifter wear normally means equal or more cam lobe wear. This badly worn lifter would instantly tell you to order a new set of lifters and a new camshaft. If the engine is low mileage and the lifters look good, inspect the camshaft. If the lobes look unworn, you could then mic them to see if the cam can be reinstalled in the rebuilt engine. Also inspect the crankshaft. If you find major wear or damage, there's no need to take time to mic the journals. Simply send the crank out to be machined. In ending, remember that every step of an engine rebuild is important. If you overlook even one step, you could end up like this block, out of service or out of a job.